All right. So let's talk about thermochemistry. When you hear the word thermo, what do you think of? Heat. Thermochemistry, also know this is, we're on chapter 6 if you're keeping track. If you're keeping track. I know.
How many chapters are in the chapter?
We'll get to chapter 19 before the year's over. So, yeah.
Running through CS.
Yes. A third. A third. We're almost a third of the way there. So, energy can also be switched with what word when we're talking about thermochemistry? Heat. Energy can be used as heat. But what can I not use heat as? What do I not want to compare heat to? Energy can be heat, but I don't want to compare heat to what? Temperature. Yes. You do not want to compare heat to temperature because we know that temperature is equal to the average kinetic energy of a substance. Temperature is just how fast the particles are moving, right? So heat only flows one way. How does heat flow?
Up and down.
Not up and down.
Right to left.
Not right to left.
Cold to hot.
Hot to cold.
Oh, that makes sense. That's funny.
You were thinking of pressure. Pressure blows. I'm doing that with my freshmen today. Remember, nothing sucks, everything blows? That was last chapter. That was last chapter. Heat only flows from hot to cold. If you have things at the same temperature, there's no heat. There's no heat. There's no heat. So you have to have two different temperatures in order for there to be heat. You guys all know this one, but officially this is called the first law of thermodynamics. What is it, Lila? No. Energy cannot be what? Be created
Nor destroyed.
or destroyed, or nor, however you want to write it.
No.
Comma. There's the second part. It can't be created or destroyed. What?
It can only be transferred.
It can only change forms. Yes. It can only change forms. It can only change forms. So there's our thermodynamics. What letter did you use for heat last year in chemistry?
T.
No.
M.
No.
Triangle.
Didn't you use Q? Yes. Yes. Q is what we used for heat. Q tells us the direction of flow. How does it tell us? Well, here's how it tells us. Negative Q lost should equal Q gain. This is so important in thermochemistry. Technically, those numbers should be equal, should be zero heat lost. Now, does it work like that? No. You're always going to lose heat somehow, but it should be equal. If Q is lost, would be exothermic or endothermic if Q is lost? Exothermic. Because I think of exothermic as heat exiting, which would be a negative sign. If I touch something that's exothermic, how does it feel? Hot. It feels hot. Feels hot. For Q gain, that means it is endothermic. It is endothermic with a positive sign. Do positive signs actually exist? No. So there's just no sign.
Just two negative signs.
Two negatives can make a positive. We will do that later today. So there's not going to be actually a positive sign, but it's going to be a positive number. Numbers without signs we know are positive. Cool? Yes? So here's what we look at. We look at two things. We look at systems plus surroundings. Do you guys see what I did there? Look at that. You see what I did there? That little extra?
Stop. You're bad. Stop. Wow.
Let me zoom in.
That was pretty good. That's pretty good. That's pretty good.
Isn't that kind of spooky? It is Boo Woo today. Just say, look at that. See other eyes? I thought that was pretty creative.
That's pretty good.
The system is a system that you are looking at. The surroundings are what? The system. If I'm saying effects, would that be affect or effect?
A.
What the system affects. What the system affects. Affects. So there are 3 types of systems.
Are we still in the first law?
That was just kind of just like a thing. It was just there. There's 3 systems. The first type of system, system numero uno, is called an open system. In an open system, both matter and energy move. Both matter and energy move. Who can give me an example of an open thermodynamic system? Did you say London?
Yeah.
That is an open thermodynamic system.
Well, I just like that.
This room,
Like the meme.
most places. Did you guys see that they stole the crown jewels from the Louvre? That's insane.
Dressed up as.
They put a ladder up to the window.
No, it was in grade. It was in grade.
So here's my question. Do you think, number 1, they melted them down?
No.
Or number 2, I was listening on a podcast yesterday. I don't listen to just like crime podcast. This is like about my investing podcast I listen to. They said there was an underground network for stolen things like that.
And they can make a lot of.
So do you think number 1, they got melted down, or 2, they sold them to like a buyer?
Sold to a buyer.
I feel like if you're stealing the crown jewels,
Like
Like,
sold
you
them
have
to
to have
somebody
a
out
buyer.
of the country.
that's what I think. So does somebody have them like on their mantle at home now?
I saw them on Facebook Marketplace.
Oh, guys, Facebook Marketplace is wild.
You're just trying this out?
I know. I can't even say the last thing I saw there on video or in this class. It was insane. I'll tell you later.
Oh my gosh.
All right? It's not even school appropriate.
Wait, are you on the robber's side or like the police side?
Okay, that's a good question. Here's what I have to say. Am I on the robber's side or the police side of the robbery?
The robbers.
Obviously,
So clever.
I think
Like they didn't even use AI. Look.
I think rules are important.
You don't know that.
I think the law is important.
But we haven't had a good heist in a
Hold
minute.
on, hold on.
But I think if you're smart enough to pull that off, it's kind of cool.
Yeah.
Okay, robber's side as long as
Am
they
I
don't
condoning
knock it down.
stealing? No.
Like if they keep
Well, are you giving credit?
Am I giving them props?
Yeah.
Yes.
Mr. Heller.
8 minutes.
Dude, they just broke the
Yeah,
window.
they didn't hurt any Heller.
I know. Yes.
Wait, did no one notice?
No, they figured it out.
Have you ever seen the movie where they steal the crowd?
Yes.
Literally that.
I know. I know. All right.
right.
Why do we get on this? Oh, someone said London, which reminded me of Paris, which reminded me of the Louvre. Okay.
Well, no, it's like the compound.
Yes. Number 2. If 1 is an open system, 2 is probably a
Closed system.
closed system. Guess what doesn't move in a closed system?
Heat. And
Matter doesn't move.
darn it.
Matter doesn't move, but energy does. What's an example of a closed system?
A closed jar of air.
Boiling
A
water
closed jar of air.
in
A vacuum.
Not a vacuum. I would say this.
That's
Water
what
bottle.
I said.
This is a closed system. Can matter move in and out? No. But guess how the outside of this feels? Cold. There is still heat conducting away. All right, so there's probably going to be some kind of conductor there. But there's no matter flowing between the wall. Nothing's getting in or out. But that's a closed system. The third type is an isolated system, which is no matter or energy movement. This is hard to achieve. That was a weird sound.
How about a vacuum seal?
A vacuum sealed
Beef jerky. Bag of
Whoa.
sand.
bag of something that doesn't conduct at all,
Yeah.
right? A Yeti. A Yeti is the closest thing we got to a isolated system. If you've ever used a Yeti,
Universe, like the Yeti's the
now, here's the thing. How long can Yetis keep stuff hot or cold?
48 hours.
24 to 48 hours. So is that truly isolated? No, it's not. If we had figured out how to make an isolated system, what would we not have at our house?
A fridge.
Refrigerators. Yes.
Is it Yeti specifically, or is it just like a cooler?
Well, the Yeti's the best.
Yeah.
And I'm sponsored. No, I'm kidding. I'm not sponsored. What if I actually was sponsored and I had to say like Yeti so many times during these notes? So make sure you get your Yeti water bottle.
Well, you don't have a Yeti.
They don't know that. So any really, really good insulated thing. Windows. If you have really good insulated windows, there's probably a vacuum layer in between your window. It's not just glass. It'll be glass, vacuum, glass. So that's an isolated system. Okay. A new equation you may see is this. Triangle E is equal to Q plus W. So guess what triangle E is standing for?
Energy.
Yeah, it's change in energy. Yes, good job. It's change in energy, hence the triangle, the delta. Q we know is what? Heat. What is W going to be?
Temperature.
No.
Water.
Thank you. Nobody could figure that out last period. Work. Thank you, Daniel.
Okay, Dan.
I said, what scientific word can you think of that starts with a W? Couldn't think of any. But it was also first period. So, work. Yes, that was a W answer. Nice job. Now, the other thing you might see is W equals negative P delta V. So, negative pressure times change in volume. So, the nice thing about these are just plug and chug equations. All right? So that you're going to get everything but one, you're going to have to substitute it in and solve. So it's pretty easy. Pretty easy. If you have a triangle E that is positive, that means work is done on the system. So work is done on the system. If I have a triangle E that is negative, that means the system does work. I just had to say it like that. Do work. System does work. I don't know why I wanted to say that, but it felt better after I said it. Yeah, do people still say that? Do work?
Yes, they say it all the time.
Yeah, that's what I thought.
Was that like a thing or something?
I don't know. It was a thing.
The 70s?
The 70s.
I was not alive in the 70s.
Wow.
I wasn't even alive till the mid 80s. Thank you.
Wow.
Are you taking your kids to the
What?
Are you taking your kids to
Jovi has pneumonia.
What? Was she gonna go?
Probably.
What class?
I can't just take one of them.
That's the trick part of the trick or treat.
That's bad, that's bad.
She got the trick this year.
What class
No, you
were
should
they
take
gonna
her.
Incredibles.
wear?
Really cute.
Yes, we heard about them.
Yeah.
You could bring just one.
What? I could bring just one, but that's not. But then Joey feels horrible. Avi's like all smug with all of her candy. You know how it's gonna be. They're sisters, okay?
Come to the green club table, we have company.
Look for
Lila
strawberry shortcake.
made a really good
I'm gonna go for
poster
the
for the Green Club thing because it grew Borax leaves. And it's like, you know, it's
Come to the science club table. We got good candy. Yes.
you interrupted
I'm sorry. Go for it. Let's eat it.
Lila's, it was so good, like half of them. Like,
I'll come around and see them all.
we're not competing against clubs here. Like, it's really good.
Flavor is this?
No, we're not.
Oh, yeah.
Environmental sustainability will always be exploding pumpkins. Thank you very much.
But once my pumpkins explode, they plant seeds, and it makes new pumpkins. Boom, sustainable. Boom, it's both. Just saying. And I'm reusing the plastic bottles. Boom, sustainability.
Hot will
How are you
pass.
splitting pumpkins?
What?
Until like science club after school?
After school. We'll be right out there, right after school.
Wait.
Stop by. All right. The other part of review for this chapter is specific heat. Everything after this will be new, but kind of fun. Specific heat. You guys know what this is? It's the heat required. It's really specific. Just kidding. To raise 1 gram of stuff, also known as substance, by 1 degree Celsius / Kelvin. You would agree, heat required to raise 1 gram of stuff by 1 degree Celsius or Kelvin. You would agree that 1 degree Celsius is 1 Kelvin. It's the same thing. Same thing, just 273 degrees away. So the equation you may have learned last year was MCAT. We use Q equals SMAT. I'm not sure what you learned last year, but AP Chem and our book uses SMAT.
Does that say of stuff?
Of stuff. By 1 degree Celsius or Kelvin. Q is equal to energy. So let's define our variables. S is, I should put units, joules. Specific heat. S is specific heat, which is going to be joules per gram degrees Celsius, or sometimes you'll see joules per gram degree Kelvin. That's the same thing. M is mass, usually in grams. And T is triangle T, change in temp. How am I going to figure out my change in temp?
Subtract.
Final.
TF, nice job, minus TI. TF minus TI. Does anybody remember water's specific heat from last year?
22.
Like 4.3.
4.184 joules per gram degrees Celsius. That's one of those things you kind of need to know, but I'm pretty sure you don't have to know because it'll be on the equation sheet of the AP test. It is also up there on the equation sheet, I think. Yep. Also with the first 2 answers from the test yesterday. Oh.
Taylor, teacher was like, everyone? I said, Clara, look up, thank you very much.
Many people missed one of those first 2 questions yesterday.
I wasn't gonna look up. You said don't point at anything.
Okay. Wow. Here is
If only that could help.
the Heller definition of calorimetry. I made this up on my own. I'm putting this in quotations because it's my quote. I like to say it's energy from here to there.
Oh, yeah.
I know. Very specific. To determine specific heat. Calorimetry. It's energy from here to there to determine specific heat. Because usually you're taking heat from one place and you're moving it to another place to determine specific heat. You did a lab like this probably in chemistry last year. This is what we're going to be doing on Monday. So what is this a picture of? What type of cup? Foam cup, obviously. Thank you. It's a foam cup. What's it filled with? Water. All right. What's this a picture of? No.
A thing upside down. What's the ribbon?
A cal.
Oh, wait.
A calorimeter.
Wait, was it in the notes?
No. It's an upside down test tube.
Oh,
I
yes.
thought upside down.
You're right, it is upside down. And what's in that upside down test tube?
Oxygen.
Heat.
Hot metal. Obviously. Hot metal.
How is it not falling into the?
Well, that's because you haven't taken your pencil and hit the test tube yet. Because once you heat that metal up, it expands, and sometimes you gotta give a little tap, tap, tap-a-roo.
Is this what we're doing in the lab?
Yes. This is what we're doing in lab on Monday. We're doing it in lab on Monday. So, let me give you some fake data. The mass of the metal is 28.32 grams. My TI of the metal, initial temperature of the metal, is 98.2 degrees Celsius. The mass of the water in the calorimeter is 54.29 grams. Oh, did boys soccer win last night?
No.
So I shouldn't bring it up next period.
No.
What was the score?
Kaylin was not
3-1.
Yeah, specifically Kaylin, I wouldn't bring it up to.
No.
Okay, that stinks.
I wouldn't.
We call him
Volleyball
Buttercup.
lost yesterday too.
Mr. Heller, please call him Buttercup. Call him Buttercup.
No, I'm not going to do that.
Girls don't love me.
Initial temperature of the cup water.
What is this?
The water in the cup.
Okay.
That's going to be about room temperature. So let's say that's 22.3 degrees Celsius. And then I'm going to have final temperature of the system. The water should go up and the metal should go down. So it needs to be greater than this and less than this. So I said it is 23.1 degrees Celsius.
So just a guess.
This is made up data. I'm going to explain this in a second. We know the specific heat of water is equal to 4.184 joules per gram degrees Celsius. So what is the specific heat of the metal? So that is what I'm going to be trying to figure out. So imagine this. We have a beaker of boiling water. Okay? So we're going to have to set up Bunsen burners. Make sure you have shoes, hair ties, all that stuff for Monday. I won't be here tomorrow, remember that. Tomorrow's your day to work on beginning problems from the book, AP Classroom, or something else quietly. Any of those are fine. You're going to boil water. You're going to put test tube tongs with metal, put that into your boiling water. We're going to assume the temperature of the metal is the same as the temperature of the water, which is going to be around 99, 98 degrees. Once it's been boiling for 5 minutes, you're going to take that and you're going to flip it into your calorimeter, put the lid on, put the thermometer on with a stirrer, and you're going to record the highest temperature that the thermometer goes up to, right? So here was the mass of the metal. Here was the initial temperature of the water, which I'm assuming is the temperature of the boiling water. The mass of the water in my calorimeter that's cold. I'm going to have, and then the initial temperature of the cup in the water. Yes?
Didn't we do something like this last year?
You did. You did something like this last year. You will need 2 thermometers, right? Why do you need 2 thermometers? Because you're going to need one for the boiling water and one for the cold water. You're not going to want to take the water that was just in boiling water and put it in the cold water because it's going to take too long to change. So you need 2 thermometers. So how will you set up your data table? How will you do this calculation? We know that negative Q lost of the metal should equal the Q gain of the H2O. So what can I solve for first? What do I have everything of? Water. So the first thing we would solve for is the Q gain of H2O. So that is equal to SMAT. SM triangle T. Here we go. So Q is going to equal 4.184 joules per gram degree Celsius times the mass of my water is 54.29 grams. What is my change in temperature of the water? It's 0.8. This was wild. I forgot to tell first period this. Good thing I'm recording this one. AP Chemistry decided to make this the Sig Dig question last year, which is wild. Here's why. If I subtract 1 after the decimal and 1 after the decimal, how many after the decimal am I going to have? 1. Because adding and subtracting is just the number after the decimal, right? Which then forced this to be my Sig Dig answer. I'll show you when we get to in the spring. So then how many Sig Digs would this, we're not going to do it on this because it wouldn't be good numbers. How many Sig Digs will this technically have? 1. That's how they did sig digs last year. Everybody missed it. That's the first time I've ever seen that in the 10 years I've taught AP Chem. It was legit a tricky sig dig question.
How evil.
So, it is evil because there's only one sig dig point out of the 40 points on the AP test.
Oh no.
And pretty much everyone missed it. I graded thousands of a question like this, and I would say less than 10% got it. Because guess what? You haven't thought about adding or subtracting sig digs since the beginning of the year. So I'll show you when we get to it. So Q equals, anybody solve it? Anyone have a calculator?
4.184 times 54.79.
Yeah.
Oh my freaking god.
Can we not?
181.71.
So let's just do 182 joules.
I thought it was 200.
Like I said, we're not going to do sig digs because that's going to give us some bad data.
Sorry.
Okay, so we know that negative Q lost equals Q gain. So that means that negative Q is equal to SM triangle T. Are you with me so far?
Yep.
That means that S of the metal is equal to negative Q divided by M delta T. Are you okay with the algebra I've just done?
Yep.
I just divided, right? So if I sub in what I know now, S metal is going to equal negative 182 joules divided by the mass of my metal was 28.32 grams times 23.1 degrees Celsius minus 98.2 degrees Celsius. Oh, snap. That's going to be a negative number. Arch? What happens when I take a negative divided by a negative?
Positive.
You get a positive. Solve that. Tell me what you get. Anybody?
Calculators.
Brooklyn's got it. Feisty.
Negative 8.03.
This is so weird.
Yeah, we're going to like. So it's negative. So you said negative
you are, you're like-
2 divided by 23.
28.32 times.
You don't.
It should be 0.0856 joules per gram degrees Celsius. I don't know why I put that in parentheses. But that should be what you got.
Okay, let's look at.
So